Okay. We're going to quickly talk about normal distribution and then z-scores and how to find percentages with z-scores. So here's a bunch of data. We just did a question on standard deviation. We discovered that the standard deviation of all this information was 23.5. Great. Also, the mean was, what was it, 162.5? Yeah. The mean, which is actually very important for what we're doing, is 162.5. So we're going on the assumption that this is normally distributed. And what that means is we assume that it creates like a bell curve around the mean if we were to graph all of this data from the sample. Okay, so here, let's say here's the middle, the mean. The mean value in our case was 162.5. We go on the assumption that the information as we gather it for the study does something like that. Okay? Okay, well, what does that mean? Well, there's a couple things. When something's normally distributed, we usually break it off into a certain amount of quadrants. Let's say this would be considered, let's say, one deviation. And they should be symmetrical. My picture isn't perfect. These would be considered maybe two deviations. And then finally, you get three deviations, which is actually a really rare event, being, well, outside of three deviations. Okay? And what we're going to find is, this being the mean, okay, that within one deviation, so when I say one deviation, I mean one standard deviation, so that's positive one, or I mean negative one standard deviation, that 68% of all of our data will fall between this. Okay? When we talk about between two deviations, so positive and negative two deviations, we're talking about 95% of all the data that we'll ever sample is going to be between these. And finally, when we talk about positive 3 deviations and negative 3 deviations, we're talking about, here is 99.7% of data. So it's almost all of the data, you could say, will fall within 3 deviations. So that's if something's normally distributed. So when they're asking us, we have all of our values up here at the top, right? These are all our data. Let's say in this question they want to know how much of the data is between 2 deviations from our sample. Okay, well, let's figure out what a deviation is. Well, how far is one deviation? One deviation is 23.5. So to be positive one deviation, we have to add 23.5. So to be one deviation away is 186, I think. Is that right? 186.
Yep.
And then to be negative one deviation away, we subtract 23.5, which I think gives us 139. Is that right?
Yep.
Yeah. Okay, so when we're comparing, what we're saying is how much of the data, if we're saying is within one deviation, is between those two. Well, our question asked us 2, so we have to take that a step farther. We do the same process again, and from 186 we add 23.5, which is going to give us 209.5, and 115.5.
Yep.
Mental math is still okay. Okay, good. So that's within 2 deviations. And then finally, to find the third deviation, we keep the same process. But in our case, they just want between 2. So we look at all the data. Well, the lowest part of that range is 115 and the highest is 209. Well, our lowest number was 120 and our highest was 99. So in this case, 100% of our data fell between the two. Okay? Between the two deviations. Well, let's get a little more specific. How much of our sample itself fell within one deviation? Well, 139 being the lowest and 186 being the highest. Well, that gets rid of the 199 and 198, right? 169 being the next highest, so that's 2. And we said there was 10 altogether, so we get rid of those. We'll put lines to it. That actually stay. And the low end being 139, so anything in the 20s is going to kind of drop off. Where we had our 120. Was that the lowest one? Yeah, everything else falls in between. So of the 10, we got rid of 3. That was 7 of 10 fell within one deviation, which is 70%. And according to, assuming it's normally distributed, that's really close to that 68%. Okay? Now let's say, and this is where z-scores come in. We have to have a z-score table. Let's say they wanted to know how much of the data, okay, in this case, using our z-score, would fall, if we were to continue this, like an actual population, how much of the data would be to the left of, to the left of one deviation to the left. So how much of the data would be below 139? Okay, well, there's a formula for z-score. So your z-score is equal to the number we're looking for minus the mean divided by the standard deviation. Okay, this is how we find a z-score. So our number being 139, okay, 139, our mean being 162.5, and our standard deviation being 23.5. Okay, so let's calculate those values. I think that's going to give us negative 23.5. Is it going to be negative 1? Yeah. Okay, and I've chosen this purposely just so we get an idea. So negative 1. Okay, so we've got to look up negative 1 on a z-score sheet. So I look up negative 1 here. And in that case, that's 0. What did you get? 0.1587. Yeah. My z-score sheet's a little different, and I would have had to do some math. I would have had to subtract this value from 0.5. Your z-score sheet's even better. What did it give you? 0.1587. Okay, so what it's saying is that 0.1587 as a decimal. With yeah, so changing the percent, what do we do? So we get 15.87% of the data is to the left of that, is less than that, okay? And that's how our z-score sheets work. So 15.87% of the data is less than 139, right? And let's want to just keep that. Because this is symmetrical, well, because that's one deviation, how much of the data would be greater than 186? Well, because it's symmetrical, we'd have another 15.87. So let's add an even further question to this. How much of the data is outside of one deviation? Well, we would add these together. And when you add those together, what are we going to get? 31.74, which makes sense. Add that to 68, what do you get? Pretty much 100, right? And we know this is 68 point something. That makes sense because we said between here is 68. So outside of here must be 31.74% of that data of the population. Okay. So this is important. This is your formula for a z-score, and you have to know how to look it up on a z-score sheet and then transfer it depending on your z-score sheet. A good one gives you the exact values. Mine was not the best one because it only does one side of it, and we have to subtract from 0.5 every time we talk about it. Okay, but it's fine. We've kind of got the idea. Does this make sense?
Yeah.